I don't know, it was really cool, but also creepy at the same time.
We got the hand reveal in that video, and the dexterity was incredible. There were 3 big essays this week. Demis Hassabis from Google, Satya Nadella from Microsoft, and Mira Murati from Thinking Machines.
Everyone who's been in like an intro computer science class knows that it's very easy to accidentally create an infinite loop, and so we haven't left CS 101, unfortunately.
Why
The dumb
is that?
done. I swear I didn't invent that term. That's like a common term.
We're back with another big week. 1X showcases their groundbreaking new robot hands. The leaders of Microsoft, DeepMind, and Thinking Machines all publish big essays in the same week, and we break down what each of them says. And then we sit down with Nnamdi Iregbulem, our Lightspeed partner mapping the infrastructure behind AI agents, to break down the loops that are running your agents while you sleep. Let's get into it.
Claire, did you watch 1X's video that broke the timeline this week?
I did. It was actually kind of, I don't know, it was really cool, but also creepy at the same time, actually being able to see a hand that was so lifelike. I don't know if you knew this, and I think I've mentioned it a couple of times, but my dad actually collects sci-fi movie props.
I did know this.
And so we have the Terminator head, and I grew up watching all these movies, and it got me thinking a lot about this kind of genre staple in sci-fi where you have these robots and they reveal like the hand. It's like in Empire Strikes Back or even in Ex Machina, this idea that the hand is always when you have that final reveal that it's like human versus robot.
Yeah, well, we got the hand reveal in that video, and the dexterity was incredible. In every other robot that we've seen to date, they all kind of like struggle to pick up a cup of coffee or anything like that. And it was really amazing to see that. What does it mean to have a robot that is able to have that level of dexterity and be able to do things like screw in a light bulb or pick up a screw like it does in the video?
The big watershed moment here and why people are so excited is because, to your point, it is such a step change from the traditional robotics that feel very rigid, like Boston Dynamics or even the Tesla Optimus. One big difference is the weight. So some of these more industrial robots are anywhere from 150 pounds to 200 pounds. I think Tesla Optimus is 150 pounds. This one is 5'6". It weighs about 66 pounds. So a lot lighter, but it does come at a hefty price tag of $25,000.
I mean, $25,000 is a lot of money to put a housekeeper in your home or maybe an elderly care person.
Yes, lots of potential use cases with this. And we can unlock all of these use cases specifically because of the big breakthrough that they've had with the hands. And so in the robotic space, there's sort of this holy grail problem. Elon Musk has called to it multiple times. It's the hands problem. The big issue with hands in robotics are that they're historically these like very massive, heavy objects. A lot of traditional robotics vary from anywhere from 5 to 8 degrees of freedom. So quite limited in how much they can do and therefore quite clunky. Actually, the head of product at X1 said that in order to tackle this, they actually started building the hands a year ago. And their first prototypes they would call actually like Popeye because the hands were so ridiculously oversized, the hands and the wrist. And it illustrates really just how hard it is to fit all of these gears and motors into a functional hand. I think in this case, they were able to achieve 25 degrees of freedom, which is close to 27 degrees found in human hands. So
Wow.
pretty insane. And they specifically have 22 in the fingers and palm and 3 in the wrist. And that gives them a positioning accuracy of plus or minus 0.2 millimeters. That allows them to do those complex actions like pinching, holding a wine glass, but also achieve strength like lifting a 20-pound kettlebell.
And that dexterity also comes with, I'm sure, a ton of more data that they can use to train their world models and continue to improve their robots and make them better and better and better with each iteration. But what does this mean? Obviously it's great for a demo, but there's thousands of things that you need to do in a house on a day-to-day basis. Do you think that these hands are going to be able to do things, like pick up on a regular basis in my home? Like what's the future of this look like?
I think they definitely want to start with the home, which is actually really interesting. A lot of robotics companies have taken the opposite approach to start in factory and manufacturing or warehouse settings, precisely because there are extremely repeatable workflows. And those are clean environments where you won't have a pet or a young child running around. If you think about the spectrum of messy robotics data and robotics situations, factory floors are easiest because lifting a box up and down is a relatively simple workflow. But a home, that's full of edge cases, to your point, like someone tripping over or a young child pushing a robot around. There's all these things you have to account for. At the same time, that gives you so much more data, and happy to chat through actually how they're processing a lot of that data. But I think in order to make this suitable for the home, they've done a couple of things. One of the big things is actually in the hand, again, a breakthrough around something called force transparency. And I won't go too deeply into the engineering, but the basic idea is that compared to traditional robotics, because the gears are so low, the joints are actually back drivable, meaning that force isn't just one direction, applied in one direction. It can actually also have information flow back. And what that means is that it can actually feel external force passing back through into the robot system. And at home, what that means is that you don't have a robot that is locked. So if a robot is, running head first, arms first at something, it can actually feel tension and the external forces and learn to stop. Or if a human or an obstacle comes across. So that's huge for safety and actually being able to put these in homes with real people. I think another thing that I thought was a big breakthrough was the material, and the hand itself is actually washable. So people actually don't think about this because we obviously haven't had robots in our homes.
Of course, if it spills some wine on its hand, you want to be able to wash it off.
Exactly. And if you truly want a home-friendly robot that is able to operate and switch between washing dishes and doing your laundry, you don't want dirty wine stains transferring into your laundry. So that's another component that actually I think a lot of people have overlooked, is the fact that these are waterproof and washable.
So interesting. Well, this launch wasn't without controversy. Wired actually decided that as opposed to, kind of looking these as like cleaning and home robots, they kind of almost sexualized them. They thought like the zipping up the jacket and some of these other things were almost being forward. But I don't know. I didn't kind of take that away from the
what did you
video
feel after watching?
I felt like the video was kind of like homey and comforting. Nothing about it made me feel like they were sexualizing robots, but I understand that, journalism is a business based on clicks, and it was a provocative headline. And to be fair, these are things you kind of think about when you think about robots. There's not just one side of a coin. So I thought it was interesting. Was it a little provocative? Probably.
Yeah, I mean, I've been thinking a lot about this idea of like the robotics form factor, and I think a lot about even what would be acceptable in my home. And I constantly come back to this idea of like, do you truly need a humanoid shaped robot for it to provide a lot of utility and function?
I know there's so many other shapes and sizes of robots.
Yeah, and if you think about the robots that exist in our factory warehouses today, all of those don't necessarily look like, you don't need a humanoid. If anything, humanoids of 2 feet and 2 legs are extremely unstable. There are wheel-based robots. There are robots that, even thinking about robots that are much more oriented around certain industrial workflows, like those don't look like humanoids. They look like humongous autonomous tractors and bulldozers. And those technically are robots because they're, again, interacting with the real world, delivering some sort of outcome and utility. And so I think robotics is so much more than just the humanoid form factor. I also think another thing that I've been curious about is just this question again, do we want robots to look like humans? I think of the movie WALL-E. There's a reason why people like robots to not look like humans. And there's almost kind of like a pet-like nature, or, some of these like home-friendly companion robots almost look more like pets rather than other humans. And I actually read, maybe this is controversial, kind of scary, but the actual origin of this is going in linguistics and I geek out over stuff. But the origin of the word robot is actually, I think it's a Czech word that means slave. So,
oh wow,
yeah, so like there's ties to that, and people have brought up this question of like, is it weird that we want a robot that is performing work in our home like a servant in the form of a human. And obviously there are questions of, can you achieve this with other form factors? At the same time, I do think it's a massive, impressive feat that they're able to achieve such precise dexterity, and maybe looking like a humanoid and having human-like hands and 25 degrees of freedom is the only way you achieve a form factor that can do all of this general reasoning across the home. And maybe where I would push back on the kind of we don't need it to look like human argument is that traditional robotics have been only focused on single tasks, like performing a certain task in a warehouse or performing a certain task in retail. But now if you truly want something that can perform both laundry and cleaning your home and mopping your floor and carrying wine glasses and taking care of a human, I think there is still an open question of maybe you do need something that is human shaped because that's the only form factor.
Yeah, maybe you need the legs to help climb the stairs
Exactly.
or help you down the stairs if you're an elderly person.
Yeah, so I see both sides, and I still think, ultimately what it will come down to is how humans respond to having something like this in the home. Neo is not 100% autonomous. We're in an era where our hardware is outperforming our software, and that's why you need all of these teleoperations to come fill in extra context. And so, for example, today when Neo runs into an edge case, it doesn't know how to carry a specific item it's never seen before. In this kind of 30 to 40% case, it will have a human teleoperator put on a headset, and then it'll beam into the robot. It'll actually have cameras, and those cameras and sensors will take over and they'll manually complete the task. There is an option to blur your face prior to a teleoperator beaming into your home. But there's been all these questions around, like, is this video footage stored locally? Are you blurring it locally versus blurring it in the cloud? Does that mean that, these companies are collecting a lot of data around people's
And there's
homes?
already been a history of lawsuits with Alexa and Google Home and, all of the Ring cameras. So this is charted territory, but still scary to have something with a camera walking around your home.
I think it ultimately comes down to the trade-offs. I mean, every time we're using the internet, we're basically giving data around our preferences. But if you are offering a utility, say social media and a way to connect with your friends, then you're willing to give up some of that data set. I think there are certain use cases, say an elderly person who might not want to go to an assisted living facility. Like, is the trade-off that I'm okay with you seeing my home if it means that, I can get access to 24/7 help?
Or
So I think there are trade-offs, and I think with everything, I just assume kind of this non-zero chance, because if you are able to extract some sort of benefit and you view this trade-off in different ways, I think it ultimately depends on the human. I also think ultimately it depends on how much utility it can provide. Right now, Neo is super slow. So it takes 2 minutes to fold a sweater and 5 minutes to load 3 dishes.
it's too long for me.
If you compare it one-to-one to Neo versus me, of course I'm going to be like, oh, I'm so much faster. I can just do it myself. But I think there's also multiple use cases where you could think of me on a 30-minute Zoom call and it's folded 15 sweaters. That's actually, if you reframe it like that, it's like allowing me to multitask on other things. Or if you think about it in the case of someone who isn't able to do this, like an elderly person or someone who needs that assisted care, then I think that's a different reframing. So I constantly think of, ultimately it comes down to end users. And I do view a category the world would find something like this really helpful. And as always, with all of these tools and products that are coming into our space, it's constantly evolving. And I think the future is being written and built as we speak. And so I'm not going to judge based off of today's product. I think really excited about vision and excited to see how they safely implement something like this in a home.
Shifting gears from physical dexterity to mental dexterity, there were 3 big essays this week. Demis Hassabis from Google, Satya Nadella from Microsoft, and Mira Murati from Thinking Machines. What were they? What were the similarities, and what did they say?
Yeah, they're 3 big names. I'm sure, in the AI world, these are household names. And so for there to be 3 big essays, I was like, oh my gosh, each of them have different manifestos.
A lot of people have things to say this week.
Yeah. I thought all of them were really fascinating. They were actually all talking about relatively different things. So it's not like they were putting out essays in response to each other. I would say Demis's one is the most practical. Maybe we start with that one just because that one, he talks about the institutional changes we need to make in the AI space.
Yeah, much more of like a call for unity around having some rules around AI.
So the basic gist of what he said was that AGI is no longer a distant concept. He actually even says it's probably a short few years away. And he compares the magnitude of this technology's impact almost like 10x the Industrial Revolution at 10x the speed. So insane to think about that scale. I think one of the lines that I loved coming out of this was that he basically lays out with AI, we've essentially found a way to make sand think. Like if you think about semiconductors and silicon and sand, we've made sand into this unit of intelligence, which is such an exciting
Such a
time.
beautiful statement.
But at the same time, lots of risks. So he mentions all these risks around cybersecurity, bionuclear. We talked extensively about this on podcasts. And it makes sense. I think another part is that these systems are becoming more agentic. So most people think of AI as still a chatbot, when in reality, these systems, if you implement them in the form of an agent, they can have goals, they can break down the goal, learn from their failures, loop autonomously. And so we are building systems that can act in the world without our inputs. And because of that, I think all of us agree that there is this precious window where we need some sort of, or Demis states that we need some sort of governing body that is independent to test frontier models before deployment. So you can't just simply release things and these systems into the wild. So I think it was super practical. Agreed. I think it was also really awesome to see quotes from other big AI leaders. I think I saw Sundar, Satya, Sam Altman, all these other AI leaders who all agreed. And
how about Satya's? Because Satya's was very different from Demis's. I feel like he was all about, we are teaching AI every single day. Every time you make a correction, every time you're like, no, don't do that, do it this way, you're teaching AI a little bit of your institutional knowledge.
Mm-hmm.
What does that mean and imply for the big model companies? What was he trying to get across?
Yeah, he had an essay called The Reverse Information Paradox. And his basic claim is that there is a hidden cost to the way that we're running AI today. You kind of alluded to it. But it all starts with this basic economics idea by this economist called Kenneth Arrow. And there's a classic information paradox. So his core idea is that if you're a seller, you are giving information a risk. You can't demo or sell information without giving it away. So that's the classic information paradox. Satya flips this on its head, and he says that actually in the AI era, unlike traditional markets where if I'm a seller, I'm giving away knowledge, in the AI age, there's almost like a reverse problem where the buyer is giving away their proprietary knowledge, improving the model, to make the thing that they purchased more useful. And so he argues that companies effectively pay twice, once in the actual raw value of like paying for tokens, but also once in the secrets.
When they're teaching AI how to do what they do best.
Yes. And he I think one thing I love the way that he phrased it is this idea of an intelligence exhaust, that as someone who is a knowledge worker, every time I'm using these models, every time I'm updating it, I am saying that, no, actually, you should phrase it like this way. Or if I'm in a code base and I make another alteration, it is imperceptibly capturing all of this knowledge exhaust and learning from you. And because in AI, we have this concept of reinforcement learning from human feedback, your daily workflow becomes that exhaust. And so he argues that companies should ideally be able to control their learning loops, because otherwise all these loops flow into the core model providers.
But at the same time, like every big company is already doing this today. We're all using AI. What is he suggesting that we change in order to, maybe flip the paradox?
There are some practical things. For starters, at a high level, he says the enterprises need to own their means of production.
Yes.
And really establishing these hard trust boundaries. So Some practical things like owning their own learning loops,
Yep.
having private evaluations, being able to have proprietary learning environments so that all the intelligence that they're generating, this intelligence exhaust, compounds for their benefit as opposed to all feeding into the core model.
And how about Mira's? Hers was a little bit more philosophical. Would be curious your take on what Mira was trying to get across and how it maybe differed from what Demis and Satya said.
Yeah, this one, I think if Demis's was the most practical and Satya's was the most economic and business oriented, Mira's, I think, was the most like epistemological, philosophical argument around what even is knowledge. How do we, as a society, generate knowledge? And so her basic argument in her essay is that if you look at the trajectory of AI development, a lot of the models that we have are frozen, and they're very central. So that she says that these big labs, there are very few of them, and they dictate the value and voice of AI. So it's sort of like the central planning of the mind, and that if we just let AI do everything automatically, humans will lose their skills and power. And so she calls for decentralized AI, which is shaped by more tacit, local knowledge of people themselves and the people it serves. And what she means by that is that we should build AI so that anyone, me, you, a chef, a shopkeeper, they can tweak the AI to match their own specific knowledge and values. And so instead of having this one boss AI, you actually have an ecosystem of different AIs that almost reflect she calls it the weirdness and diversity of real people. And what that means is basically to this idea of like being able to customize it to your own voice, being able to customize model weights. So users being able to train and fine-tune model weights as opposed to just improving that over a prompt, which is just very surface level. I think another thing that you can see with what Thinking Machine Labs have built out with their interaction models is this idea that we can't just be limited by these small text boxes. We need to have some sort of like live multimodal interaction where humans can interrupt, correct, and influence AI in real time. And then I think, the very natural one is this idea that we need to have new evaluation metrics. So we need to move away from measuring how long AI can work autonomously and all these benchmarks to actually measuring what people and machines can accomplish together. So a lot in there in the three pieces. I'm curious, was there one that stood out to you more than others?
I think Mira's for me was the standout, mostly because it was about like not having monoculture AI, right? Like you can kind of see what she was saying where it was about like how the parents in AI train the children of AI and they all kind of inherit a lot of the sameness. And you start to see that in the models that we use today, right? Like you're like, oh yeah, I kind of recall this is the way the last AI worked. And so you realize that there is actually value in the diversity of thought, and having that expressiveness in AI felt kind of aspirational. And I think what was interesting for me about all three of these is it's kind of saying AI is happening quite quickly and it's happening even faster than we expected. How can we kind of chronicle what's happening now and maybe influence a little bit of the future and where it's going? So each of them were aspirational to me, and also master classes, I think, particularly Demis's, in just like really great corporate communication.
You got your marketing hat on.
No, I have to put it on. It was a really good piece. I think all of them did their jobs, but I think, if you think about that kind of unity and what he was looking to accomplish, felt like he hit the nail on the head.
Yeah. I feel like there are all these seminal essays and pieces that these AI leaders put out, and it's been interesting to see the development and what people got right, if things have changed based off of some of these manifestos and essays. And yeah, just really exciting time to live in right now. This week, our guest is one of our very own. Nnamdi Iregbulem is a partner here at Lightspeed, where he invests in AI infrastructure and developer tools. And he often shares his writing and research in the field. Today, he's taking us one level up to the topic that everyone seems to have questions around: loop engineering, the cycle that lets AI work on its own. And we discuss how it works, where it breaks, and how to think about what's next. Nnamdi, welcome to Lightwork. So Nnamdi, I am so excited to have you on here because you are one of my go-to resources for anything agent, infra, and you have spent so much time in this ecosystem. And so we figured, now that we're hearing a lot about loop engineering, you might be the perfect person to demystify all of that for us. For starters, I think it's been buzzing the last few weeks just around this concept of moving from harness engineering to loop engineering. We've heard from Boris Cherny that he's no longer prompting and now he's just architecting loops. So we'd love for you to help us break down what is this evolution, what even is loop engineering, and then we'll go through a little bit deeper into an anatomy of a loop and how we set some of these up. But really excited to have you on, and thank you for taking the time.
Yeah, no, thanks so much for having me. Very excited to talk about this topic. I think, as you mentioned, things are changing very rapidly, and loop engineering as an expression has just emerged on the scene in just the last month or so, and everybody's talking about it now. And so happy to help kind of demystify a bit of it. A nice place to start before we go anywhere else is just, in very simple terms, like, what is loop engineering? I almost just sort of abstract from all the details and describe it as the practice of getting an agent to behave over a very long timeline productively and successfully without human intervention. That's really what it is at the end of the day. And I know it's easy to be thrown for a loop by loop engineering, pun intended, but it's really just as simple as that.
Nnamdi, can we take a little step back? I mean, you put so much work into this beautiful Lightwork light board. Could we maybe start just at the beginning, at the most like earliest stage, at that like center box there where, prompt engineering was the moment back in 2022 to 2024. We all read so many X threads about how to prompt AI, and it was all about what to put into the text box. From there, and then all of these other boxes that have grown around it, help us understand, what takes us from that very humble beginning to loop engineering.
Yeah, it's been a bit of a journey. Happy to kind of take us all on that journey. Starting with prompt engineering, like you mentioned, this was sort of the term du jour, back when generative AI kicked off as a category. And really, the simplest way of thinking about prompt engineering is, like, I almost make an analogy to a newborn baby. It's like the first words that are spoken to the baby. What are those? That's all a prompt is, in effect. It's a collection of words sent to a model, and it's the first kind of information that the model is receiving that it wasn't trained on, right? These models are trained over massive corpuses of information from across the internet. Suddenly it wakes up one day and new information comes in. That is the prompt. It kind of makes sense that we started here. If I think about, like, what is so interesting and unique about this generative AI moment, what is interesting about large language models, it's that they speak our language. And so intuitively, the place to start is kind of what's most intuitive to us, which is just the words that we speak to the model. And it turns out that because those are the first things that a model sees, they are extremely impactful towards how the model behaves as it goes along its work. And so, it made sense to kind of start with prompt engineering. Prompt engineering is not dead by any means. Like, honestly, like, long live prompt engineering. But things have kind of evolved since then as various complexities have emerged. Breaking out of this first box, we get to context engineering. And almost the way I would think about that is, if you think about the entirety of a agent trajectory, parts of that are the outputs of the model itself. Part of that is what the human says to the model. And so that's kind of the prompt engineering. And then part of that is essentially programmatic or other kinds of responses from the environment in which the model is operating, the context in which the model is operating. That's really what context engineering is at the end of the day. It's all the things that the model basically sees and gets to interact with as it's going about its work. To make another analogy to a baby or sort of a growing child, in the same ways that, as a baby is growing up, you might tell it different white lies along the way, like, hey, Santa Claus is real. One day Santa Claus is not real. In the same way, we kind of tell these white lies to the models, right? It's not about every fact about the world stuffing it into the model's context window. It's about selectively picking parts of the information that are most relevant to the model doing what it has to do, feeding that in at the right time, feeding it in at the right sequence, maybe even going back and deleting things that you had previously told it in order to ensure that it best stays on the rails for what you're trying to get it to do.
I have a quick question. As you think about context engineering, it is, as you've laid out, it's almost like giving a model ability to see things at inference time. What does context engineering entail? Like, what things are you tweaking or giving to the model?
It's a good question. So there's sort of a canonical set of behaviors that a model can kind of take as it's interacting with the rest of the world. And so like one example is reading a file on your computer or in the environment. Another is doing a web search on the internet. You imagine that even though the models were trained on a bunch of internet data, the internet's a constantly evolving thing. And so there's new, fresh information that the model hasn't been trained on that could be useful for it doing what it needs to get done. A company that we have in our portfolio, a company called Exa, was one of the first to really kind of create any AI-specific search engine and API that's optimized for the use cases of AI agents. And so a lot of folks are using them to solve that, like, what the model sees, which is your context plus like the broader web.
And say a little bit more about why we need even a search engine for AI agents. What I think going back to basics, like why can't AI use Google the way that humans do, and why isn't Google as a search engine set up for the way that agents operate through the web infrastructure?
Yeah, the best way to think about it is to almost just think about the history of how Google came about. When the internet first emerged, thousands became millions, became billions, became trillions of individual pieces of content out on the web, impossible to sort through as a human. And so you needed some sort of abstraction over which to ask what you're looking for and get back a bunch of reasonably relevant responses to what you're looking for. That's just, search in a nutshell. And so it kind of made sense that a company like Google emerged to solve that problem. Google came up in an era of where the main kind of agent acting on the web was a human. And there are various optimizations that you make to serve the needs of humans. There's also various optimizations you make to sell a lot of ads. And so that's sort of the objective criterion of the Google search engine as traditionally defined. Now, agents are different. They behave differently. They have different needs. Different things are optimal in terms of the content that you might want to serve to them. And so it makes sense that you might want a different search engine specifically for the needs of those agents. And this is a subtlety that I think a lot of people missed. But the Exa team, Jeff and Will over there, were very early to this. Actually started Exa before ChatGPT even took off. And at this point, they're kind of one of the go-to options for search on the web for agents. So
you've taken us through prompt engineering to context engineering, each layer kind of wrapping around the other. That feels kind of unique, right? Like it's not like we just got rid of prompt engineering or we got rid of context engineering. Explain that and then maybe take us to the next layer.
Yeah, I think it's one of the interesting things about all of this is that it's not that anything is getting replaced. It's really just getting layered on. And all of these practices are still relevant today. In fact, they're more and more relevant because people realize that there's all these kind of pieces of high leverage across these different parts of the stack. Imagine you held the prompt constant. Don't change the prompt.
Mm-hmm.
How much variance in model behavior is there still, even if you hold the prompt constant? Turns out there's a lot. Depending on the context in which the model is operating, it can behave very, very differently, even with the same exact prompts. Okay, now let's hold the prompt constant, the harness. The kind of most famous harnesses, Claude Code, of course, OpenAI has Codex. There's a really up-and-coming open source harness called Pi that I really like. There's a bunch of these that have kind of emerged over time. And so this term of harness engineering has come about. Generalization and kind of formalization of context engineering, where we say, okay, what are the different pieces of context? It's like the tools, it's the files, it's the memory of the agent over time, it's various parts of your enterprise context. How can we kind of formalize that in a particular way of doing things for the particular agent that you have in mind? And so a bunch of options have emerged, like I mentioned, Claude Code, et cetera, that are kind of off-the-shelf harnesses that you can use and adopt in your enterprise and work pretty good out of the box. And then there's others that are kind of emerging that people are either building themselves or kind of open source or alternatives that are customizable. I think one of the things that's always most interesting, going back to my point around the amount of variance in performance that can still happen at this layer, you can look at benchmarks of agent performance, hold the model constant, but give it different harnesses. And it's kind of shocking how much that can affect the behavior on a particular benchmark, even though in some sense, all of the intelligence is inside of the model.
That's really interesting. I almost think of like what you're saying is that these are all different levers that you can tweak and still get vastly different outputs. And so in my head, it sounds like prompt engineering is giving model optimizing for sentences and words. But then you have context engineering, which is giving it the ability to see beyond this and into the real world, almost like the eyes. And then harness engineering, what you're saying is almost like maybe, if you will, like a body around that brain, able to like actually use tools, kind of that product layer. And so what was missing from all of that we needed loop engineering?
Good question. In some sense, nothing was missing, right? Like a lot of productive work can get done with this construct, even excluding this concept of loops. And that's a point I want to make to people is one should not look at loop engineering as like, oh my God, it's this thing that I now have to go learn because otherwise my agents are not going to be useful. It's really just a way of describing, in many cases, what you're already trying to accomplish with these agents. And like, what are you trying to really accomplish? You're trying to get the agent to take on more and more work over extended periods of time without human intervention. I think almost everybody using AI in various ways is in some sense trying to get to that outcome. And loop engineering is just the practice of how do you make that happen? An analogy would be, for folks that are maybe coming from sort of like the chatbot realm, if I'm having a chat with Claude in the Claude web app, I say something to Claude, it says something back to me. It's this interactive kind of synchronous conversation. I'm doing that with you right now. And, if I'm being a good conversation partner, I'm not going to monologue for a day. I'm monologuing right now, but in general, I'm not going to monologue for too long before getting a response back from you. And importantly, if, we're talking right now and I were to sort of just get up and, walk away, that would be the end of the conversation, right? It's because it's a synchronous thing. With agents and with loops, imagine that, I say something to you, I say, hey, 1, 2, 3, X, Y, Z, we good? You say yes, and then I bounce. I go watch a movie. I'm going to go watch Odyssey this Friday. I come back 3.5 hours later, and you've done a bunch of productive work. It's almost like a pen pal that you send a letter to, and then a week later, something comes back with all this rich information and all the things that were happening in your life and what have you. So you can imagine that's very powerful, but it also has a lot of, I would say, risk associated with it, importantly, opportunity cost. Because suddenly, if that model goes off the rails and I only find out about it a day or two later, that's a day or two of lost time. Versus if I say something to you right now and you don't hear me, you can just ask me, come again, like, what did you say? We can get back on track very quickly. And so that's why loop engineering is such an important concept, because the gains to be had are enormous, but the costs are also, severe if you get it wrong.
And so it sounds like the human's job is if you build the right loops, you're moving from an operator or, someone having a synchronous conversation to an architect, someone that's actually building the system that's able to have a looping autonomous agent. I'd love to break down the actual anatomy of how this actually all works. And as someone who is architecting all of this, how do you think about building the right loop? What goes into a good loop?
It's one of these things that it seems very intuitive as soon as you sort of explain it. One reference I like to make is actually, there's this concept called an OODA loop. I don't know if folks might have heard of this. It actually came out of the US Air Force, but it's basically a decision-making framework for you're in combat, you're going through the motions, you're collecting your information, and you're deciding how to act upon that information. This was invented, decades ago, but interestingly enough, it's basically the same thing that we're doing when we're talking about loop engineering. And it's observe, orient, decide, act. That's the OODA loop. In some sense, that is exactly what these agents are really doing. And they're just, the whole point is to just get them to productively do that for extended periods of time. For our purposes, I think it's fine to sort of collapse the observing and the orienting into one bucket. So I'll just talk about that as being, singular. Basically, you start with a goal, right? Provided by the human about what is the objective, what are you trying to get done? And importantly, what does good look like? And how do you know that you're done? Then the agent sort of takes some actions in the environment in which you've placed it. It observes how the environment reacted to its actions. It collects new information. It then decides what to do next based on that information with really two main options. One is there's more to be done, in which case you go back to act and you kind of start looping. Or you say, hey, job's done, and then you exit, you're done. All of what we've talked about here fits into various places within this loop very nicely, in fact. The prompts is just the goal. That's all it is. It's the goal they initially feed the model. Files, the tools, the other parts of context just fit into both the actions that a model can take based off of those tools and the information that's going to get back when it observes the reaction. Things like, termination and error handling. Basically, how does a model know when it's done? How does a model know when something has gone wrong? How does a model know what good looks like? That all feeds in to deciding and being done. If you've constructed this in the right way, done should mean done. Done should mean I got back what I wanted. Done should mean it looks the way it's supposed to look. Done should mean that no guardrails were tripped. If you don't do this right, done can mean all sorts of things. And this is one of the subtleties that kind of emerges as people start to work with these things. This is actually very tricky to get right. And so hence the conversation we're having right now.
So interesting. I feel like this looks more like running a great team than like making software.
I think that's right, which is, by the way, I think partly why it requires kind of a shift in mentality in the same way that, engineers coming up in the organization will have to pick between the IC, individual contributor track, and kind of like the management track. And those require kind of different ways of thinking about things. It's the same here. And, some people are handling this transition very well. For others, it's a bit of a struggle. But I think that's exactly the right way of thinking about it.
I have a lot of questions because, I think you alluded to what happens when these loops go wrong and, the risk of maybe even infinite loop in this era of not trying to token max. We can talk about that. But before we get into that, I think trying to break down some of these steps, specifically on the goal, I'm curious, this idea that you need a testable termination. What is a good definition of a goal? I think it sounds like if you just say improve the code, that is too vague. But how do you set up a goal such that your loop is set up for success?
I think about it basically in two potential ways. So one is kind of a deterministic goal as verified by ideally a deterministic system like your computer, which can basically just say when X is true, end the loop. That's kind of I would say, the most foolproof way of going about it. And X could be when all the tests pass. X could be when the website is live. X could be when, the email is successfully sent to the customer. It can mean a number of different things. And then there's kind of, I would describe it as sort of non-deterministic, kind of model verified stopping points, which are basically, I would think about as basically criterion that the model is kind of smart enough to figure out itself whether it has accomplished that thing or not. And, you have to be very careful about not assuming that the model is smarter than it actually is. But if you can get those right, there's a lot of leverage in doing that because the model can basically figure out for its own purposes whether it's done or not. And so ideally, these goals are as straightforward, objective, and ideally deterministic as possible. Getting this right is super important because, to your point, you can end up kind of unwittingly token maxing by the model sort of like looping infinitely. And everyone who's been in like an intro computer science class knows that it's very easy to accidentally create an infinite loop. And so we haven't left CS 101, unfortunately.
Moving on to observing and deciding, though, it sounds like a core part of that is the verification layer and a model checking on itself. And you've mentioned how, we can't necessarily trust the model to grade its own output. Or models to grade even other models' outputs. How are you thinking about providing feedback in this loop?
Yeah, it's a little bit of it is, I think there's some like principles, like I was mentioning, that are kind of universal. And then there's going to be a lot of things that are particular to the context in which you're operating and your environment and your task and what have you. I do think that models will get more and more useful at doing verification work. More and more things people, are going from the realm of like, either you could deterministically verify them or you couldn't verify them at all, to even non-deterministically, you can get to a pretty good point. In fact, there was a paper recently out of Stanford, a guy named Jackie Kwok, and the title is LLMs as a Verifier. And they talk through a paradigm, a kind of framework for how to use LLMs as actually pretty good verifiers in certain contexts. it uses a decent amount of tokens, but it gets you to the outcome. And so I think that will kind of continue to develop over time. But for now, one has to be very careful about what verification means in your context and not get too far ahead of yourself.
And maybe even just going into where some of these loops might even break down in failure modes, I'd love to highlight a couple. It sounds like one of the big things I've been hearing a lot about is this idea of like context overflow and that, it's hard to take all of that context engineering and make sure that it runs reliably. Tell us a little bit more about what that is and why you might run into that.
As folks might know, models only have so much sort of capacity to ingest a stream of tokens. Today, like a common context window limit might be 270,000 tokens or whatever. Sometimes, some models have 1 million tokens or what have you. And agents, if you go back to that sort of decomposition of the overall trajectory of the agent, again, it's the outputs of the agent, it's the inputs from you, and then it's the inputs from the environment. As an agent goes through its loop, it's basically stacking these on top of each other, almost appending them one after the other for every turn of the loop. So as you can imagine, after, some number of turns, that gets pretty long. Mm-hmm. And you can literally run out of capacity of the context window of the model, and you don't want to end up there. The other issue actually is not even that you've fully used, like the full capacity of the model, but that, let's say you're here, like 50% mark. It turns out the models get a lot dumber in this zone. The
Why
dumb
is that?
zone. I swear I didn't invent that term. That's like a common term. And so even though you haven't exhausted the full context window, you don't want to end up here. And so the actual usable portion of the context window is actually, quite small. And so how do you sort of manage around that? How do you sort of engineer around that? This is sort of kind of emerging practice and something where, the best teams are doing some really interesting things to deal with this exact issue.
On the dumb zone, I've heard of maybe even a adjacent issue where agents run into agentic laziness. They might hallucinate success at this 50% mark. So tell us a little bit more about why they're even able to hallucinate success or why they get lazy.
Yeah, so there's a couple things going on there. I'll draw like another line. We mentioned earlier, the issue of like infinite loops, right? So imagine this is like the timeline of the execution of an agent. You don't want it to end up in the sort of like infinite zone. That's bad. But imagine that the goal is successfully accomplished here. And let's say you have reasonable certainty that if the model goes that far, it'll generally accomplish the goal. A thing that sometimes happens is that models will get what's called lazy, where they'll just kind of stop at a certain point and ask you for a response. And it's somewhat understandable, right? Because these are conversational chat bots. That is the history of these things. And so at some point, it does need to ask you it needs to end its monologue and ask you to comment. So to some extent, it's a very forgivable sin. But if it hasn't accomplished the goal, then again, the opportunity cost is very high. Because imagine you've set this thing out to do what it needs to do. That takes maybe a day. It turned out that at hour 3, it just gave up or it just stopped. And you only come back after 24 hours. So that's a bunch of lost time. And there's oftentimes no way for you to know that it stopped. I know people are getting fancy with various ways of talking to their model at a distance, but you can see why this is problematic. And so a lot of work at the labs is going into how do you get these models to behave over these very long trajectories, to push through where, those initial stopping points and continue for extended periods of time. There's also a bunch of work happening on the side of what teams can do themselves to ensure that this doesn't happen. We have a portfolio company called Protrotis, which is working with a lot of the labs on generating the training data that would get the models to behave over these long trajectories in these digital contexts. And so you can think about them as basically helping provide the data that enables this loop to go on for a very long time at the level of the model's own intelligence. We also have a company that we work with called Temporal, which is in that second bucket. What they work on is this idea called durable execution, which is exactly what it means. How do you execute over long time horizons in a durable, reliable way? And that's a technology that anyone can go and use for themselves as they're crafting these loops in order to ensure that their agents stay on track and keep going to the goal.
A big part of this, yes, is the architecting on your own. But I think a second order effect is we need some way of observing these tools as they run long horizon tasks and run autonomously for hours on end, days on end. Do you feel like there's also a layer of companies building around that observability? How are they alerting people about when, a model might be goal drifting or when it might be getting lazy?
In any, kind of infrastructure like system or application, especially when you get to production, you eventually need observability. You want to know what's going on, when it's going on, and ideally be able to remediate or kind of react to what's happening. And we have a couple companies that are working on exactly that. The two I'll mention is a company called Judgment Labs and a company called Raindrop. And what they're both sort of doing is, imagine as you run these loops, your agent does a bunch of work. That's a lot of data and exhaust about how the agent is performing, what it did, why it did it, what went right, what went wrong. It would be amazing to collect that information and use that to make the next run go a bit better. That's in effect what these companies do. That's sort of an asynchronous thing you might do after the fact. And then increasingly, you'll want to kind of make these observations and remediations in real time as the agent is running. And that's sort of like an emerging practice of how do you kind of keep the model on the rails at runtime. And so between those two different components, you can get kind of full observability over the agent lifecycle, both in kind of after the fact, almost like after action reports, and in a kind of like at runtime, let's keep on track, guys, and keep going towards the objective. So I would say that's kind of like the full picture there.
Yeah, almost like performance tracking for agents.
Yeah. And I also think, like Claire and I earlier were talking about Satya Nadella's piece this week, which was all about kind of observing agents and what you provide that helps them get better and better every single time. And it's interesting to see this entire wrapper of stacks like building around, the foundations of the model layer.
I think another piece that I was reading over a lot this week was, Nnamdi, your piece on agent-oriented file systems. That feels like an open space, and it feels like that is really important for some of the context problems that we were discussing earlier. I'd love for you to share a little bit more about how you're thinking about that space and why agents even need a file workspace.
Yeah, it's sort of funny. If you think about the history of computing and how the modern computer emerged, as they were thinking about how to represent information on the machine, they looked to kind of the way that they represented information in the analog, real world. And you had these file cabinets with a bunch of folders in them. And the folders had all the documents and the information. And so it was very natural and intuitive to basically import that concept to computers. And we've basically been living with this kind of file folder paradigm over the last 50 plus years, coming back from that original heritage of how the computing came about. Ironically, this is sort of making a return exactly because these models were trained on information of humans interacting with computers through the file system.
Oh.
And so the model very naturally understands a lot of these concepts and how to kind of like navigate the file system and what tools are available to it and what have you. How's it structured? What does it look like? In a weird way, the ideal environment for an agent is the file system, files and folders and various commands to interact with them. This idea of like file systems as the idea kind of construct or environment for the agent has sort of emerged, especially in the last year as agents have taken off. And there's all sorts of, founders thinking about, how to better shape that for the agents, going forward and how to kind of surround the agents with the right sort of like file system to make it as native, to make it as easy to use, as possible. But it's a great starting point when the model already kind of knows what it's doing, on your laptop's hard drive.
That's super helpful. As you look at everything that you've laid out, this has been such a comprehensive walkthrough, and you've been so helpful in breaking this down for us. Are there any spaces you feel like still need to be developed, other levers, now that we have prompt engineering, context engineering, harness engineering, loop engineering, or is there another lever that we can pull as we work with agents? Where are you seeing some of these, opportunities and gaps in the market?
Yeah, it's interesting, right? There's a lot going on here. But AI moves so quickly that for anything that I've mentioned here, there's a bunch of founders and interesting companies going after various components of it. So in a weird way, there's like no white space, but in another way, there's a lot of white space because there's just no way that we've yet reached the optimal solution in each of these buckets. This is a constant kind of iterative process. People are discovering new techniques and paradigms all the time. The models are getting better all the time. And so what is optimal to provide the model changes as the model itself gets better and smarter, et cetera. And so it's kind of this, ever evolving game, and there's no particular stopping point. One thing I'll mention is sort of like an interesting space where I'm personally very interested in looking for more companies is, I've been a developer tools investor for like the last decade. And you think about Git as this sort of version control collaboration paradigm for coding in particular. Coding agents are probably the most popular kind of agent. And for the same reasons that they very naturally understand the file system, they very kind of naturally understand Git. They almost understand it too well. And so they push it to the limits. And if you think about like GitHub, amazing product, amazing organization, it's buckling under the weight of all the commits from agents, from everyone's agents of all sorts and kinds, committing to the system and essentially running into rate limits, downtime, etc. And going back to my point earlier about opportunity cost, any wasted time at all is super, super expensive. And so there's this kind of idea emerging of what would like a more agent native or agent ideal, Git like system look like, and how could that system serve not just coding agents, but all kinds of agents? Because if you look at most agents that people build, they are effectively coding agents. They're coding agents where the task might not be producing a software artifact, but it's the same model most of the time. It's the same, very similar set of tools, etc. And so there's a world where, you think about like the future of work where, the lawyer interacting with the agent, that agent is interacting with essentially a Git-like and file system-like construct. The customer service person interacting with agent, interacting with a file system, construct. The accountant interacting with an agent is interacting with a file system in a Git-like construct. And so feels like something is there. Haven't yet found the exact thing that looks like that, but it's one I'm sort of thinking about all the time. And yeah, if you're working on this, like, please reach out to me.
Yeah, I'm sure coming out of this, there are so many ideas. There are so many people working, as you mentioned, across this entire stack. But it's really exciting time. I'm sure we'll tap you in a couple of months. It feels like there might be another iteration of this, hopefully, and we can build on all the previous whiteboarding that we've done. But thank you so much for joining us. And as Nnamdi mentioned, if anyone's building in this space, make sure to reach out to him. He's truly the go-to resource for me for anything AI agents.
Amazing. Nnamdi, thank you so much for joining us on Lightwork. We really appreciated your expert whiteboarding.
Thank you. Yeah, and if we do another one, we'll have to get a bigger whiteboard because we're kind of out of space on this one.
I know, we're running out of space.
Yeah. Thanks, guys.
This has been so helpful. I feel like just a couple of months ago, we were out here talking about harness engineering. It keeps changing. Now we're in loop engineering. I'm so glad that Nnamdi was able to demystify all that for us.
Right? Satya told us what not to put in the loop, and then Nnamdi taught us what the loop is all about.
I don't know if I can hear loop one more time.
I know. That's enough loops for this week on Lightwork.